Okay, this lesson is about percent composition. Finding the percent composition is about finding the percent by mass of each element in a compound. This can be helpful for identifying whether two compounds are the same or different. Remember, when we do percentages, it's always a part over the whole times 100. And it's often used to determine if compounds are the same. Kind of said that. Well, sometimes the problems will give you a mass to follow along with. For example, calculate the percent composition of a compound formed when 29.9 grams of silver reacts with 4.30 grams of sulfur. Well, first we have to figure out what the total amount is so we can do part over whole. The whole is 33.3 grams because I add the 29.9 and the 4.30 together. So those two numbers added together, 29.0 plus 4.30 is 33.3 grams. Then to find the part that's silver, I take the 29 grams divided by the 33.3 times 100, and that's 87.1%. And the sulfur is 4.30 grams divided by 33.3 grams for the total, times 100, which I'm not showing here on the slide, is 12.9%. And then these two percentages should add up to 100. Sometimes you're not given the masses to use, so you have to use a chemical formula. For example, the problem might say, calculate the percent composition for sodium phosphate. The first thing you have to do is to write the formula correctly. So you have to use the periodic table. The correct formula for sodium phosphate is Na3PO4. Sodium is +1, phosphate's -3, Na3PO4 formula. So next we're going to find the molar mass of the sodium phosphate. What we're doing is we assume that we have a 1 mole sample. So by assuming 1 mole, I need to calculate the mass of 1 mole to be the total amount that goes on the bottom in the denominator. There are 3 sodiums in the formula, so 3 times 23. There's 1 times phosphorus, so 31 for that. 4 times 16 for oxygen, and if I add it all together, it comes out to 164 grams per mole. That's what I'm going to use for my whole amount, the bottom of my percentage. The sodium is 69.0 divided by 164.0. That's this 3 times 23 right here. Gave me this 69. The phosphorus is 31 over the 164 times 100. Remember, don't forget these are all being multiplied by 100, but I left it off the screen because there wasn't room. 18.9% phosphorus, and the oxygen is 64.0 over 164.0 times 100. That's 39% oxygen. Let's do some practice with percent composition problems. This one is giving me a formula and no other numbers to use, so I assume I have a 1 mole sample. The first step is to find the molar mass. There's 1 potassium, 1 manganese, and 4 oxygens. So potassium is 39.1, manganese is 54.9, oxygen is 16.0. Multiplying across, 1 times 39, 1 times 54.9, 4 times 16 is 64. Total of these is 39.1 plus 54.9 plus 64, 158. 0.0 grams per mole. That's the molar mass. That's what we use for the whole. And to get the parts, we're going to do for potassium 39.1 divided by 158 times 100. $39.1 divided by 158 times 100, 24.7% K. Next we do the manganese. 54.9 divided by 158.0 times 100 equals 34.7% manganese. And for the oxygen, 64 over 158 times 100 . Forty point five percent oxygen. So your answer would be all of these: 24.7% potassium, 34.7% manganese, 40.5% oxygen. Shall we try the next one? The next one is find the percent composition of hydrochloric acid. This one doesn't give us any numbers, so we assume 1 mole. So the first step is to find the molar mass. (36.51 or 36.5 grams per mole). The percent hydrogen is 1.01 out of 36.5 times 100, and the percent Cl is 35.5 out of 36.5 times 100. The math on the hydrogen is 2.77% hydrogen. And for chlorine, (97.3% CO). Notice that these should all add up to 100%, or be really, really close.